What if, at this very moment, realities beyond our own are not just existing quietly in the background but are actually touching, overlapping, or even colliding with our universe? What if the strange mysteries we observe in physics, space, and time are not random glitches, but subtle fingerprints left behind by other universes brushing against ours? This idea may sound like pure science fiction, but surprisingly, modern physics does not completely reject it. In fact, some of the most advanced theories in cosmology and quantum mechanics suggest that parallel universes might be real, and under certain conditions, they might interact. The question is not only whether parallel universes exist, but whether their presence could already be affecting our reality in ways we do not yet fully understand. Welcome to Information World. To understand the possibility of colliding universes, we first need to step beyond our everyday understanding of reality. Our intuition is built on human-scale experiences, solid objects, linear time, and a single continuous space. But at the deepest level, the universe does not behave in intuitive ways. The laws that govern galaxies, particles, and space-time itself are far stranger than anything our senses evolved to comprehend. In modern cosmology, the idea of parallel universes does not come from imagination alone. It emerges naturally from serious scientific frameworks. One of the most well-known is the concept of cosmic inflation. According to inflation theory, the universe underwent an extremely rapid expansion fractionally after the Big Bang. This expansion may not have happened just once. Instead, it could be an ongoing process, constantly generating new regions of space-time, each one effectively becoming its own universe. In this picture, our universe is like a bubble floating in a vast cosmic foam. Other bubbles may exist beyond our observable horizon, each with its own physical properties, laws, and constants. These bubbles are normally separated by immense stretches of expanding space. But under certain theoretical conditions, they could collide. If two universe bubbles were to collide, the effects would not look like a conventional explosion. There would be no fireball, no shockwave traveling through space like a movie scene. Instead, the collision would distort space-time itself. It could leave subtle imprints in the structure of the universe, especially in the oldest light we can observe, the cosmic microwave background. The cosmic microwave background is often described as the afterglow of the Big Bang. It fills the entire universe and carries information about its earliest moments. Scientists have studied it with extraordinary precision, mapping tiny temperature fluctuations across the sky. Some researchers have noticed unusual patterns, cold spots, and asymmetries that are difficult to explain using standard cosmological models. One speculative but serious idea is that these anomalies could be scars from collisions with other universes in the distant past. Not proof, but intriguing hints that something beyond our universe may have influenced its evolution. Parallel universes also appear naturally in quantum mechanics through what is known as the many worlds interpretation. In this framework, every quantum event that has multiple possible outcomes actually realizes all of them. Instead of one universe collapsing into a single outcome, reality branches into multiple universes, each representing a different result. In this view, parallel universes are not far away in space, but layered within the same quantum reality. Normally, these branches do not interact. They quickly decohere, meaning they lose the ability to influence one another. However, some physicists have explored the idea that under extreme conditions, interactions between branches might be possible. If such interactions occurred, they could manifest as subtle violations of expected quantum behavior, small deviations that are difficult to detect but not impossible in principle. While no confirmed evidence exists, the mathematics does not entirely forbid it. Another theoretical framework that allows for interacting universes comes from string theory. String theory proposes that the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings existing in higher dimensional space. In some versions of the theory, our universe exists on a three-dimensional membrane, or brane, embedded in a higher dimensional space known as the bulk. Other universes could exist on neighboring branes, separated from ours by an extra dimension. If these branes were to move or fluctuate, they could collide or interact. Such a collision could release enormous energy and potentially resemble a Big Bang-like event. Some cosmological models even suggest that our universe itself may have originated from such a collision. In this context, collisions between universes would not be rare accidents, but natural events in a higher dimensional landscape. Their effects might be subtle or dramatic, depending on the scale and nature of the interaction. If parallel universes were colliding right now, what would we actually observe? This is where speculation must be grounded carefully in physics. We would not see other universes visually. They would not appear as objects in the sky. Instead, we would detect indirect effects anomalies that cannot be explained by known physics alone. One possibility is unexplained gravitational effects. Gravity is unique among the fundamental forces because it interacts with space-time itself. If another universe were influencing ours gravitationally, it could cause unexpected motions in galaxies or distortions in cosmic structures. Some researchers have explored whether unexplained cosmic flows or anomalies in galaxy distributions could hint at external gravitational influences. Another possibility involves dark energy, the mysterious force driving the accelerated expansion of the universe. Dark energy accounts for roughly 70% of the universe's total energy content, yet its nature remains unknown. Some speculative models suggest that interactions with other universes or higher dimensions could manifest as dark energy within our own universe. Time itself could also behave strangely. If universes with different temporal structures interacted, it might lead to subtle irregularities in the flow of time at extremely small scales. While such effects would be incredibly difficult to measure, precision experiments in atomic clocks and quantum systems continue to push the boundaries of what we can detect. Even the fundamental constants of nature might offer clues. Constants like the speed of light, the strength of gravity, and the charge of the electron appear finely tuned for the existence of complex structures. Some scientists argue that this tuning is evidence of a multiverse, where many universes exist with different constants, and we simply inhabit one that allows life. If universes were interacting, it might lead to slight variations or instabilities in these constants over time or space. So far, measurements show remarkable consistency, but the search for tiny deviations continues. It is important to emphasize that none of this is confirmed. Science demands evidence, and extraordinary claims require extraordinary proof. The idea of colliding parallel universes sits at the edge of what current technology and theory can test. But being speculative does not mean being meaningless. Many ideas that were once considered untestable eventually became central to physics as technology advanced. Black holes, gravitational waves, and the expansion of the universe were all once theoretical ideas without direct evidence. Today, they are observed realities. The multiverse may follow a similar path, or it may remain an elegant explanation that nature simply does not use. What makes this topic so compelling is not just the science, but what it implies about our place in reality. If parallel universes exist, then our universe is not the entirety of existence, but one chapter in a much larger story. Collisions between universes would mean that reality is not isolated, but interconnected at levels far beyond human perception. This challenges deeply held intuitions about uniqueness, causality, and existence itself. Events in our universe might not have purely internal explanations. Some causes could lie beyond our cosmic horizon, forever hidden from direct observation. At the same time, this idea reminds us of the humility required in science. The universe has repeatedly shown that it is larger, stranger, and more complex than we initially believed. Each time we thought we had reached the limits of understanding, new discoveries expanded the boundary. So, are parallel universes colliding right now? We do not know. There is no direct evidence that they are, and it is entirely possible that they never interact at all. But the fact that modern physics allows for the possibility and that we can even begin to search for clues speaks to how far human understanding has come. Whether parallel universes exist or not, the pursuit of these questions drives science forward. It pushes us to develop better theories, more precise instruments, and deeper ways of thinking about reality. And in that pursuit, even unanswered questions have immense value. If you enjoyed exploring this idea and want more deep, mind-expanding science content like this, don't forget to like the video and subscribe to the channel. It really helps information world grow, and it lets you stay connected to more fascinating discoveries about our universe and beyond.